What's up? 11.4, experimental design. Last section we looked at populations, samples, and now we'll dig into more specific of that, like how do we get samples, how do we get populations, what do we do with it, and more specifically in an experimental way. So what are we going to do? We're going to describe experiments, so maybe things will tie in from other classes. We always need randomization for a good experiment, so recognize how randomization applies between these two terms. Hopefully you know what an observational study is. If not, that's okay, we'll go over it. And then look at a design. Is it good? Is it bad? What can we do with it? So, for these terms to know, maybe you've seen some of these in a science class, but a controlled experiment is when you're running an experiment with identical conditions except for one thing that we are changing. And that one thing we will change between our control group and our treatment group. Our control group gets ordinary conditions, and our treatment group gets what we are testing, our treatment. Randomization is how do we randomly assign subjects to different treatment groups. And then we say that a randomized comparative experiment, keyword randomized means randomization, comparative means we have two groups to compare. The subjects are randomly assigned to either the control group or the treatment group. A placebo, used a lot in medical studies, is a harmless, unmedicated treatment that resembles the actual treatment. So if you see any medical drug on the market, usually they run through these trials where people will get either the medication or a pill that looks exactly like the medication but doesn't have any actual effect. And then replication is being able to repeat an experiment under the same or similar conditions. Now we mentioned an observational study up top. An experiment is when they are assigned at random to two groups. That's the key part of an experiment, is we have one group, usually volunteers, and we randomly assign them to either the treatment group or the control group. Observational study is when random samples can be selected and groups are being studied, but the key thing there, and I'll put a little note, is that there is no random assignment. That people are not randomly put into groups in an observational study. So that is the key thing there. To compare studies, if we have a good comparative experiment, eliminating sources of variation, and other than the controlled variable, we can make a cause and effect. That's why we have such rigorous studies for anything medical, is that if we control as many things as possible and we keep only the placebo and the drug different, then we can draw cause and effect and say people got healthier because of this medication, or they didn't. And then an observational study, only correlation, so no cause and effect in an observational study. So they have no random assignment, and because of that, they have no cause and effect. So we'll get into that when we're analyzing our studies. But let's look at experiment 1 right down below. Okay, example 1. To test whether baby videos that highlight words and introduce music and art can improve language ability, parents with babies 0 to 24 months were given a choice of whether to let their babies watch the videos. 50 babies who watched the videos were observed for a year, as well as 50 babies who did not watch the videos. At the end of the year, the babies who watched the videos scored higher in a language development test. Question 1. Is the study a randomized comparative experiment? Did they compare? Yes. Were they randomized? Does it say anything about, I'll use the term up here, did they use any random assignments? And let's read it again. We're given a choice. No. So it was not randomized, so no. It was not a randomized comparative experiment because they were given a choice. So if it was yes, we will give the treatment group and the control group, but it is no. So we're not going to do A, we're going to do B. Explain what conclusions you can draw. Up here, here's our conclusions. Because it is not this, we have to go here. We can talk about correlation. We can say there's an association between the two. So we can say, explain the conclusion you can draw. we can say watching the videos is associated with higher test scores, but not causal. C-A-U. Not causal, because we did not have a comparative randomized experiment. If we had that, we can do a cause and effect. But because we didn't do it, we can just do an association, but not a causal relationship. And we say that because who knows if it was really the videos doing it? It could be one of a lot of things going on. Like maybe the parents who are having them watch the videos, they're also reading to them more, and they're taking them out to museums and libraries, and maybe it's because of one of those reasons. We don't know, because they weren't randomly mixed up. So maybe all the parents who are on top of helping their kids learn also had them watch the video. So we don't know. We can't draw cause and effect there. But let's see another one that might be. In a clinical trial, 100 type 1 diabetic patients volunteered for a new drug. 50% of the patients received the drug, and the other 50 received a placebo. After 1 year, the patients who received the drug had better glucose control, while the placebo group experienced no significant change. Now on this one, is it comparative? Yeah, it sure is, because we got a placebo and we have the drug. So we're going to compare those two groups at the end of it. Was it randomized? I really wish they put the word in there. We can assume that it is. This is a clinical trial. They're not going to screw around and not randomize things. It will be. I wish they would put randomly in here. And for our intents and purposes in class, I'm going to make sure that that's clear. Like, you would hope that they say randomly receive the drug, but we can assume that they are because it is a clinical trial. So we're going to go ahead and say yes on this one. We'll be more clear with our questions. So because of that, we can describe the treatment group. They received the drug. EIV, received the drug. And the control is the ones that everything else is normal. They didn't even receive the actual drug. They received something that looked like the drug. They received the placebo. And so because our answer wasn't no, we'll cross it out. That's why I didn't give you any space. Number 3, explain whether the research topic is best investigated to an experiment or an observational study. Now, sometimes we can't do things in experiment through reasons. Experiment is best, but we can't always do it. Then describe the design of the experiment or the observational study. A criminologist wants to know whether social factors cause criminal behavior. All right. As much as we'd love to get a cause and effect, we have to do observational study here because we can't randomly assign people to commit crimes. As much as some YouTuber might try to do that, we can't do that on a big factor. So, because of that, we must have an observational study. And it's not ideal because an observational study only allows you to do associations. But, you know, again, back to what I put in red. You can't randomly assign people to commit crimes. You got to do an observational study. Then describe the design. We would want to analyze different places with different social factors and compare criminal behavior. So we'll analyze different parts of the country. We'll see how they have different social factors, and we'll see, is crime different in those places? And then again, we can't do a cause and effect, but we can see, is there an association between those things? Versus B, a drug company wants to know whether a new medication on heart disease has side effect on individuals. Yeah, you better do an experiment. There's nothing preventing us from running an experiment here. It happens all the time. So, what does it look like? We could have one large group of volunteers and randomly assign, keyword randomly, assign them to treatment or control group, where one would get the drug, the other, I assume, would get a placebo. All right, last part, number 4. A company wants to test the effectiveness of a new moisturizing cream designed to help improve skin complexion. Identify a potential problem, if any, with each experimental design, and then describe how to improve it. Part A. A company randomly selects 10 individuals. 5 subjects are given a new moisturizing cream, and the other 5 are given a placebo. After 8 weeks, each subject is evaluated and determined that the 5 subjects who have been using the cream have improved skin complexion. Overall, solid. We got random assignment here. We got 5 subjects given the new, 5 given the placebo. After 8 weeks, we're evaluating, so it's a good amount of time there and determine whether they have skin improvement. So a word that's not used in here, make it randomized. Maybe it was, but they just left that out. Randomized. And maybe this stood out to you, maybe it didn't. That's not a lot of people. 10 is not a lot of people. Who knows how varied their skin complexion is? You would want to get a lot more people, because we could just have 10 outliers here. We want to get a lot of people to really compare this. So what we can do is get many more people for this experiment. 10 is just not enough. Like, let's get some more. Part B. A company randomly selects a large group of individuals. Half the individuals are given the moisturizing cream, and the other half of the individuals may use their own existing moisturizer or none at all. After 8 weeks, each subject is evaluated and is determined that a significant large number of subjects who receive the moisturizing cream have improved skin complexion. Okay, so they solved that first problem. A large number of individuals. Half are given the moisturizing cream, the other half of individuals are using their own or none. I don't like this part. Their own or none. Take you back to a definition on the first page. For a controlled experiment, we want one variable to be different. But here, you're allowing people to choose either, hey, do some or none at all. So you'd want to designate, maybe you'd have 3 groups. So we could either say, make groups either all do existing or none at all. Not both. That's a key problem there. BOTH. Because that just adds in an extra variable to it. You want them to be as similar as possible. So I'll put in a note, maybe do 3 groups. Do one with new, existing, and none. And compare those 3 groups. There's nothing saying we can't do 3 groups to compare. Maybe that's something you want to do. All right, we're at that 15 minutes. So describing experiments. So could we describe how to do something, how to randomly assign, what are we comparing? Recognize how randomization applies to experiments and observational studies. So experiments, cause and effect. Observational studies don't have randomization, no cause and effect. And then analyze experiments like we did in example 3 and number 4. Maybe you need to clear it up in class. That's okay. We'll run one together, and we'll analyze it together to see the big points that we're thinking about, and bring whatever questions you have after that. I'll see you then, guys.